Hello, welcome back. So, this will be the last episode about this Google Cloud platform course where I'm basically going through this reliable Google Cloud infrastructure design and process. Okay, so this is the last module of this course. It will take a bit to complete it. Therefore, let's
Final
go.
module of this course, we cover application maintenance and monitoring. Maintenance is primarily concerned with how updates are made to running applications, the different strategies available, and how different deployment platforms support them. For monitoring, I discuss this vital area for cloud-native applications from two perspectives. First, I will talk about the cost perspective to make sure that resources are being best provisioned against demand. After all, why should you pay for resources that you don't need? Second, I will discuss how to implement monitoring and observability to determine and alert on the health of services and applications using cloud monitoring and dashboards. This will also allow us to define uptime checks and use cloud monitoring alerts to identify service outages. Let's get started.
Let's go. Therefore, now we have.
Let's begin by taking a look at version management. A key benefit of a microservice architecture is the ability to independently deploy microservices. This means that the service API has to be protected. Versioning is required, and when new versions are deployed, care must be taken to ensure backward compatibility with the previous version. Some simple design rules can help, such as indicating the version in the URI and making sure you change the version when you make a backward incompatible change. Deploying new versions of software always carries risk. We want to make sure we test new versions effectively before going live, and when ready to deploy a new version, we do so with zero downtime. Let me discuss some strategies that can help achieve these objectives. Rolling updates allow you to deploy new versions with no downtime. The typical configuration is to have multiple instances of a service behind a load balancer. A rolling update will then update one instance at a time. This strategy works fine if the API is not changed or is backward compatible, or if it is okay to have two versions of the same service running during the update. If you are using instance groups, rolling updates are a built-in feature. You just define the rolling update strategy when you perform the update. For Kubernetes, rolling updates are there by default. You just need to specify the replacement Docker image. Finally, for App Engine, rolling updates are completely automated. Use a blue-green deployment when you don't. Finally, for App Engine.
Sorry, so typically you have multiple instances of a server behind a load balancer. Running update work when it's okay to have two different versions running simultaneously. Running updates are future instance group. Running update are the default in Kubernetes and completely automated in App Engine. Okay.
Kubernetes, rolling updates are there by default. You just need to specify the replacement Docker image. Finally, for App Engine, rolling updates are completely automated. Use a blue-green deployment when you don't want multiple versions of a service to run simultaneously. Blue-green deployments use two full deployment environments. The blue deployment is running the current deployed production software, while the green deployment environment is available for deploying updated versions of the software. When you want to test a new software version, you deploy to the green environment. Once testing is complete, the workload is shifted from the current, which would be the blue in this case, to the new, the green environment. This strategy mitigates the risk of a bad deployment by allowing the switch back to the previous deployment if something goes wrong. For Compute Engine, you can use DNS to migrate requests, while in Kubernetes, you can configure your service to route to new pods using labels, which is just a simple configuration change. App Engine allows you to split traffic, which you explored in the previous lab of this course. Now, you can use canary releases prior to a rolling update to reduce risk. With a canary release, you make a new deployment with the current deployment still running. Then you send a small percentage of traffic to the new deployment and monitor it. Once you have confidence in your new deployment, you can route more traffic to the new deployment until 100% is routed this way. In Compute Engine, you can create a new instance group and add it to the load balancer as an additional backend. In Kubernetes, you can create a new pod with the same labels as the existing pods. The service will automatically divert a portion of the request to the new pod. In App Engine,
cost planning is an important phase in your design that starts with capacity planning. I recommend that you treat capacity planning not as a one-off task, but as a continuous iterative cycle, as illustrated on this slide. Start with a forecast that estimates the capacity needed. Monitor and review this forecast. Then allocate by determining the resources required to meet the forecasted capacity. This allows you to estimate costs and balance them against risks and rewards. Once the design and cost is approved, deploy your design and monitor it to see how accurate your forecasts were. This feeds into the next forecast as the process repeats. A good starting point for anybody working on cost optimization is to become familiar with the VM instance pricing. It is often beneficial to start with a couple of small machines that can scale out through auto-scaling as demand grows. To optimize the cost of your virtual machines, consider using committed use discounts, as these can be significant. Also, if your applications are fault tolerant and can withstand possible instance preemptions, then spot instances can reduce your Compute Engine costs by up to 91%. Compute Engine provides sizing recommendations for your VM instances as shown on the right. This is a really useful feature that can help you select the right size of VM for your workloads and optimize costs. For more details on spot VMs, see the Google Cloud documentation. A common mistake is to over-allocate disk space. This is not cost efficient, but selecting a disk is not just about size. It's important to determine the performance characteristics your applications display. The I/O patterns, do you have large reads, small writes, vice versa, mainly only read data? This type of information will help you select the correct type of disk. As the table shows, SSD persistent disks are significantly more expensive than standard persistent disks. Understanding your I/O patterns can help provide significant savings. To optimize network costs, it is best practice to keep machines as close as possible to the data they need to access. This graphic shows the different types of egress, within the same zone, between zones in the same region, intercontinental egress, and internet egress. It is important to be aware of the egress charges. These are all not straightforward. Egress in the same zone is free. Egress to a different Google Cloud service within the same region using an external IP address or an internal IP address is free, except for some services such as memory store for Redis. Egress between zones in the same region is charged, and all internet egress is charged. One way to optimize your network costs is to keep your machines close to your data. Another way to optimize cost is to leverage GKE usage metering, which can prevent over-provisioning your Kubernetes clusters. With GKE usage metering, an agent collects consumption metrics in addition to resource requests by polling pod metrics objects from the metrics server. The resource request records and resource consumption records are exported to two separate tables in a BigQuery dataset that you specify. Comparing requests with consumed resources makes it easy to spot waste and take corrective measures. This graphic shows a typical configuration, where BigQuery is used for request-based metrics collected from the usage metering agent, and together with data obtained from billing export, it is analyzed in a Looker Studio dashboard. Earlier in this course, we talked about all of the different storage services. It is important to compare costs of the different options as well as their characteristics. In other words, your storage and database service choice can make a significant difference on your bill. Your architectural design can also help optimize your costs. For example, if you use Cloud CDN for static content, or memory store as a cache, you can save instead of allocating more resources. Similarly, instead of using a data store between two applications, consider message queuing with PubSub to decouple communication between services and reduce storage needs. The pricing calculator should be your go-to resource for estimating costs. Your estimates should be based on your forecasting and capacity planning. The tool is great for comparing costs between compute and storage services, and you will use it in the upcoming design activity. To monitor the costs of your existing service, leverage the Cloud Billing Reports page as shown here. This report shows the changes in costs compared to the previous month, and you can use the filters to search for particular projects, products, and regions as shown on the right. The sizing recommendations for your compute engine instances will also be in this report. For advanced cost analysis, I recommend exporting your billing data to BigQuery as shown in this screenshot. You can then analyze the billing data to identify large expenses and optimize your Google Cloud spend. For example, let's assume you label VM instances that are spread across different regions. Maybe these instances are sending most of their traffic to a different continent, which could incur higher costs. In that case, you might consider relocating some of those instances or using a caching service like Cloud CDN to cache content closer to your users, which reduces your networking spend. You can even visualize spend over time with Looker Studio, which turns your data into informative dashboards and reports that are easy to read, easy to share, and fully customizable. The service data is displayed in a daily and monthly view, providing at-a-glance summaries that can also be drilled down to provide greater insights. To help with project planning and controlling costs, you can set a budget. Setting a budget lets you track how your spend is growing towards that amount. Set a budget name and specify which project this budget applies to. Set the budget at a specific amount or match it to a previous month's spend. Set the budget alerts. These alerts send emails to billing admins after spend exceeds a percentage of the budget or a specified amount. In our case, it would send an email when spending reaches 50%, 90%, and 100% of the budget amount. You can even choose to send an alert when the spend is forecasted to exceed the percent of the budget amount by the end of the budget period. In addition to receiving an email, you can use PubSub notifications to programmatically receive spend updates about this budget. You could even create a Cloud Run function that listens to a PubSub topic to automate cost management.
Let's get into monitoring and visualizing information with dashboards. Google Cloud unifies the tools you need to monitor your service SLOs and SLAs in real time. These tools include monitoring, logging, trace, error reporting, and profiler. All of these enable you to gain the insights you need to achieve your SLOs and determine the root cause in those rare cases that you do not achieve your SLOs. Dashboards are one way for you to view and analyze metric data that is important to you. This includes your SLIs to ensure that you are meeting your SLAs. The monitoring page of the Cloud Console automatically provides predefined dashboards for the resources and services that you use. It is important that you monitor these things you pay for to determine the trends, bottlenecks, and potential cost savings. Here's an example of some charts in a monitoring dashboard. On the left, you can see the CPU usage for different compute engine instances, and on the right is the ingress traffic for those instances. Charts like these provide valuable insights into usage patterns. To help you get started, Cloud Monitoring creates default dashboards for your project resources as shown in this screenshot. You can also create custom dashboards, which you can explore in the upcoming lab. Now, it's a good idea to monitor latency because it can quickly highlight when problems are about to occur. As shown in the slide, you can easily create uptime checks to monitor the availability and latency of your services. So far, there is a 100% uptime with no outages. Latency is actually one of the 4 golden signals called out in Google's Site Reliability Engineering, or SRE book. SRE is a discipline that applies aspects of software engineering to operations whose goals are to create ultra-scalable and highly reliable software systems. This discipline has enabled Google to build, deploy, monitor, and maintain some of the largest software systems in the world. I've linked the SRE book in the slides of this module. Your SLO will be more strict than your SLA. So it is important to be alerted when you are not meeting an SLO because it's an early warning that the SLA is under threat. Here's an example of what creating an alerting policy looks like. On the left, you can see an HTTP check condition on the Summer01 instance. This will send an email that is customized with the content of the documentation section on the right.
In this design activity, use Google Cloud's pricing calculator to create an initial estimate for deploying your case study application. The pricing calculator gives you a form for each service, which you fill out to estimate the cost of using that service. For example, in this screenshot, I calculate the cost of one custom SQL instance with 4 cores, 16 gigabytes of RAM, and 500 gigabytes of SSD storage. This could represent the orders database of my online travel application. Some of these estimates aren't easy to generate, because you might not know how much data your storage and database services need, and how much compute your deployment platforms require. However, it can be more challenging to estimate things like network egress or the number of reads and writes. Start with a rough estimate, and refine it as your capacity plans improve. Refer to activity 13 in your workbook for similar cost estimates for your case.
Okay, so let's see. I will put this in pause. And let's go here. So cost estimating and planning. Use the price calculator. Itinerary, service definition. And this will be the interview form. Ticks. Okay, Google Cloud resource. So this one will use global load balancer. I want the network. Yeah, okay, so then we'll have itinerary definition service. All these services will be run as an app engine. Then we'll have SQL databases. We'll use Cloud SQL. And yeah, the analytics will use BigQuery. Ingress data, traffic. Well, I mean, this will be cloud similar. This will be BigQuery. So when I collect analytics with BigQuery, maybe Looker. Okay, so Looker Studio or just Looker. Okay. So let's go to the price calculator. I will use load balancer. Yeah, we'll have an IP address. Europe. Let's say Madrid. let's say 2, I don't know. 1. Let's say 0. Let's say 2. Sorry, but I'm kind of confused. Cloud load balancing, this regional. I will say global because customers will arrive from all over the world, and I will stay in Madrid. Number of forwarding rules. The number of global or cross-region forwarding rules across a load balancer type. I will say 1, I don't know. Amount of inbound data per month. Inbound data. I will say 1 giga. I don't know, let's say 10. If you say 100, it's cheap. So 100 gigas, maybe. Let's see how it changes for 1000 for outbound. Internal application load balancer. This will be in Madrid. Number of proxy instances. I will say 1. Amount of data processed. Shit, in reality, yeah, I mean, let's say 2. Let's say 5. It's not changing the price. Great. Amount of data processed. In this case, I will say 100. Let's say. Oh, nice. So let's add another estimate. App engine. Okay, so App Engine in Madrid, Belgium. Number of instances. Let's say 5. How much do they cost? 1. 3. 2. Nice. So if you have one instance running the entire month, then the instance time will be okay. Nice. Okay. I'm not sure here. Let's say F2. Okay. Data transfer, outgoing network traffic. I will say 100 gigas. Okay. Add estimate. So App Engine and Cloud SQL now. Yeah, MySQL. The region will be Madrid if possible, otherwise Europe West 1. Enterprise. Number of instances, let's say a couple. DB standard 2. Yeah, it's okay. Even DB standard 1, I mean. Enable high availability configuration. Yeah, let's say yes. Storage provision amount. $500. Shit, that's a lot per month. 100. High availability. Okay, high availability, but 50 gigas. Okay, so it will be 100 at the beginning. Shit. Still a lot, man. Maybe reducing the machine type. No, I mean, I will put a small, just one instance. High availability configuration. Okay, add estimate. Therefore, we have this, and well, maybe BigQuery. So additions on demand, region, regional. Belgium, amount of data required. Oof. Queried. I will say 1 tera. Active logical storage. The amount of storage has been modified. Let's see, 1. Let's see, 5. Yeah, that's reasonable. Okay, so I'm noticing that memorizing stuff costs a lot. Okay, let's see, locker. Doesn't have it. What else? Well, I will use cloud storage, regional. European Union standard storage. Ah, shit. let's say standard storage. Let's say we have like 5 people coming and having photos without 50 giga monthly data written. Total amount, fuck, this will be 500 maybe. Monthly written 500 monthly data read with Google Cloud, within Google Cloud. Well, I wouldn't really use it within data transfer within Google Cloud, not so much. Source region Europe, destination region oh shit, source region let's say Asia. Okay, that's not bad. Cloud GPU, let's see here. We had a lot of stuff. So travel available, like the availability and all this stuff in reality will increase our costs. I'm for sure not considering this in a proper way. Okay. So it will be an application load balancer. That's it, I think. Yeah, it's, oh shit, in reality the cloud storage thing will be used also for view. Shit. Multi-region European standard storage, total amount of storage, monthly data written. Maybe it's, yeah, monthly data written within. I hope like 1 failure maximum each month. So let's say 10 gigas. And then data transfer between Google Cloud. Imagine we have a failure. We have a backup of 50 gigas, I'm not sure. That's the maximum. Okay, therefore we have this estimated cost of 300. Oh, download, open detailed view. Nah, I don't want a detailed view. Let's say in euros. So we have this price here. Look, actually App Engine is costing a lot too. But yeah. Okay, now we can make a screenshot, but I don't care actually, like yeah, like let's write 100, oh sorry, so minimum Okay, so we completed the workbook.
In this activity, you are asked to use the Google Cloud Pricing Calculator to estimate the cost of your case study application. Here's a rough estimate for the database applications of my online travel portal, ClickTravel. I adjusted my orders database to include a failover replica for high availability and came up with some high-level estimates for my other services. My inventory service uses cloud storage to store JSON data stored in text files. Because this is my most expensive service, I might want to reconsider the storage class or configure object lifecycle management. Again, this is just an example, and your cost would depend on your case study.
Okay, let's continue. Now we'll have a quick lab. I'm not sure in what it
We start this
consists.
course with a discussion on defining SLOs and SLIs for your services. This helps with the detailed design and architecture and helps developers know when they're done implementing a service. However, the SLIs and SLOs aren't very useful if you don't monitor your applications to see whether you are meeting them. That's where the monitoring tools come in. In this lab, you will see how to use some of these tools. Specifically, you will examine logs,
Let's
view profile
go.
information, explore tracing, monitor your resources using dashboards, and create uptime checks.
Let's start this lab. There are 6 tasks. Let's go. So this is the password, and I want it in English. Understand. I agree. Now task 1, download a sample app from GitHub. Okay, this is kind of strange. So they want, first of all, run the following command in Cloud Shell to confirm that you are authenticated. Okay, account active to set active account, run list project. Command output update property to create a folder called GCP login, run the following command. Okay, let's go in this folder. Clone a simple Python Flask app from GitHub. So git clone Google Cloud Platform Training Data Analyst Git. Change to deploying apps to GCP folder. Sorry. Okay. Okay, now we got it. We go to this folder, we open the editor, expand the folder, blah blah blah, and click on main, add the following import statement at the top of the file. So we go into main, which is in training courses design deploying. Okay, Google Cloud Profiler. Profiler allows you to monitor resources. After main function, and the following code snippet to start Profiler after line 11. Profile will continuously report application metrics. Your code should look like this. This code simply turns Profiler on once Profiler starts reporting application metrics to Google Cloud. So you also have to add a Profiler library to your requirements txt. Okay, Google Cloud Profiler and protobuf. Profiler has to be enabled in the project. In Cloud Shell, enter the following command. Google Cloud gcloud services enable cloud profile Google IPs.com blah blah blah. To test the program, enter the following command to build a Docker container of the image. So we're building a container, then we are going to run the image. Okay, now we will deploy the program to App Engine and use Google Cloud Tools to monitor it. In the Cloud Shell code editor, in the Explore pane, select deploying apps, click File, App YAML. Okay. Save your changes. In a project, an App Engine application has to be created, blah blah blah, gcloud app create and the region. Now deploy your app with the following command. Okay, this will take a bit if I don't remember. If I remember correctly, it will take a minute or more. Okay, on the Google Cloud Console, blah blah blah, App Engine dashboard by default. Okay, click on the link to test your program, refresh your browser. The versions, technos column, the logs. Okay. Yeah. So I think that with this we will complete the major parts of the biggest part of this lab, because after what I can see is that we'll only have to explore the possibilities with the logs. Okay, nice. Okay, now it looks like it's done. Okay. Oh, what I'm doing, I'm not sure. Maybe. Yeah, who cares? What was the last command I sent? Okay, so it was the deploy command. Okay. Oh, now I can go to the application in App Engine. Hello, GCP. Okay, return to the console and click App Engine version. In diagonal column of the table, click logs. Sorry. Versions, diagonals. Logs. The logs should indicate that the profiler has started and profilers are being generated. If you get to this point too quickly, wait a minute and click refresh. Okay, so I have Cloud Profiler agent version, blah blah blah. Nice. View profiler information in the Google Cloud Console title bar. Type profiler and blah blah blah. Profiler. So the gray bar at the top represents the total amount of CPU time used by the program. The bars below represent the amount of CPU time used by the program's function relative to the total. At this point there is no traffic, so the chart is not very interesting. Throw some load at the application. Yeah. Well, I mean, how can I throw some load at the application? Fuck you. On the navigation menu, click Compute Engine, click Create Instance to create a virtual machine, select US West 1, accept all the defaults and click Create. So I will create a virtual machine to put some load on it. Okay. US West 1, okay. Okay, my instance is being created. Let's see if it will check it as completed. Nice. When VM is ready, SSH into it, log into it, authorize. Let me install Apache utils. Okay. Therefore, now we perform these commands here. Update your project ID with your project ID from connection details panel and enter the following command to generate some traffic to your app engine application. So AB my project ID is this one. Let's go. Read failed, close connection. Man. App engine. Is it actually working? Yeah, it's actually working. But why now is showing it here? Well, okay. Whatever. Okay, now we have something more interesting. Each bar represents a function. The width of the bar represents how much CPU time each function consumed. Okay. Bootstrap inner run, profile service, collect, profile. Yeah, okay, I don't know how to read them exactly. But this is not important now. Explore cloud trace. So return to the SSH window where you entered the Apache Beam command previously, which means that I need to go here. Authorize, yeah. Enter the IP command again. Oh, fuck you. And yeah, I need this. Okay, let's go to Trace Explorer. Okay, next. This is a request under latency. Okay. Let's see if we have dashboards, App Engine. Okay, so we have all these requests here. Nice. So yeah, cool. We have all these tools to monitor. Now task 5, monitor resources using dashboards. On the Google Cloud Console, monitoring infrastructure, dashboards. Okay. Click on App Engine in the left pane, click Dashboards. Click on the VM instances dashboard. What the fuck? App Engine, projects. Okay. Nice, yeah. Then click on the VM instances dashboard and select your instance. Where is this VM instances? Okay, one VM. Nice. Okay. Task 6, create an uptime checks and alerts. In the left pane, click uptime checks. And then click the plus, create uptime check, link at the top. Okay. For now, I'll close this. Which was uptime checks. Create uptime check. HTTP URL hostname. So we'll put this appspot.com. Root 1 minute. Continue. And review section, enter. In review section, enter App Engine uptime check in title. Okay. Click test to verify that your uptime check can connect. Okay. When you see a green, click create. Now, in the uptime checks page, click on 3 vertical dots next to your uptime check and select add alert policy. Okay. Notifications and name, click in notification, click on drop down arrow next to notifications channel. Add new for email. Sorry. What? Manage, okay. So now we go to email and we can add a new email. Example at mycompany.com. Okay. In the create email channel dialog box, enter your personal email address. Click on save. Okay, I already saved it. Go back to the previous tab, click on notifications channels again. Okay. Now select your display name. Okay, uptime check alert. Create policy. Okay. Nice. Return to the Open App Engine tab in order to disable the application to see whether your uptime check and alert policy work. Oh, so. Click disable application. Where is that? Click settings. Disable application. Okay. Now if we go here, it should not work anymore. Let's go to monitoring, and we shall be able to see time check. Nice. Okay, so it's not working anymore. Click alerting. Check your email. Okay, return to the app engine, select the enable application, the return check page. Return in, check your email again, edit notification, find. Okay, I will end the lab here. This is clear, and we already have been here for a long time. This was a good laboratory. Let's see if here we have something new. Yeah, look here, incident firing. Bye bye. Now let's go to the next activity, which is always, as always, a lab review.
Run every minute and see that this.
And
Okay,
yeah,
so you can see
let's
30
go.
seconds, it's failing. Here, 1 out of 3 tests.
Module quiz, 80% to pass for questions. You're deploying test environments using compute engine VMs. Some downtime is acceptable, and it is very important to deploy them as inexpensively as possible. What single thing below could save you the most money? Preemptive all machines. Your service has an availability SLO of 99%. What could you use to monitor whether you are meeting it? Availability means HTTP request 200. Uptime check. You made a minor update to a service and would like to test it in production by sending a small portion of requests to the new version. Which would you choose? Canary deployment. You've made a minor fix to one of your services. You want to deploy the new version with no downtime. Which would you choose? Oh, here I'm kind of not sure 100%. Like, let's see why this is correct. This a rolling update will update instances incrementally until all have been updated. This strategy can be controlled, for example, by using a managed instance with Compute Engine on JKey. Instead, the current deployment aims to eliminate reduced risk by applying the update to a small subset of users to test out a new feature and best fits the requirement of the question. Nice. Therefore, we finished this module.
And it's a loss.
We also finished the course, which was the longest course in this learning path, 14 hours. It was kind of
Thank you for taking the
boring
environmental
as it
structure,
was
design, and process course. We
theoretical.
hope you have a better understanding of how to design applications and services that make the best use of the platform services provided by Google Cloud.
We also hope that the design activities and labs made you feel more comfortable with design and process in Google Cloud.
Now it's your turn. Go ahead.
Okay, so depending on your plan, career path, there are different learning paths and certification you can pursue. Architecting, blah blah blah. Course have just completed forms learning path. Thank you. Let's go. So here we have the workbook. And now we have the course resources. And now we have the course survey, which will complete. Yeah, very satisfied. And next. Let's go. We finished this course. I'm really happy. Oh, it already started the next course, but yeah, let me get back here. So what happens here is that we just completed this course here, and now we're already enrolled in this one, getting started with Kubernetes Engine. We'll finish it in the next video. Thank you for being here. Let me see one thing. Why is not available? Finish, yeah. Let's view the leaderboard. Where am I? Look here. Why the points are not visible here anymore? Who knows? However, we're going good, even if it's not really important anymore. Okay, thank you again and see you in the next video. Bye bye. See you next time. Thank you for being